One of the big predictions people are making in 2018 is that GraphQL will make RESTful APIs obsolete. In today's episode, we'll learn how to build a GraphQL API from scratch using Apollo Server 2.0 and Node.js. If you're new here, make sure to like and subscribe. And I want to send a huge thank you out to Arjun Yellamenchelli. He's the mastermind behind the code in this video, and if you need a talented developer in Denver, he comes highly recommended. So let's kick things off by talking about GraphQL from a very high level. Imagine you have an Angular app that communicates with a bunch of different backend data sources. Traditionally, you would do this with either a REST API or a client-side SDK. When you hit a RESTful endpoint, it's the server that determines the shape of the data that gets sent back to the client. What happens is that you'll hit a RESTful endpoint and it will respond with a bunch of data that you don't know anything about and that you don't need. GraphQL is a query language that solves this problem by sitting in between your backend and front end. It allows the server to define exactly what data is available, and it allows the client to only request the data that it actually needs to provide the user experience. What's really cool is that you can use it with any backend data source. In this video, we'll use Firestore and set up a Node.js server with Apollo to deliver the API. This video is a two-part series. In this first installment, we will set up the backend API, and in the second part, we will use Angular to consume this API from the front end. When you set up a GraphQL API, it provides this really nice playground that you can use to start sending requests, and this just works out of the box. What we're going to do in the code is set up interfaces that describe the data that's available on the server. This is super powerful because the client can probe the backend in advance to find out what types are available and how they can be requested. This means you get amazing developer tooling even on a foreign API because you know exactly what's available and how it can be requested. You can see here I've requested all the interface names, and the ones we're interested in are tweet and user. Let's say we want to request all of the tweets from our database, but we only want the ID and the number of likes. All we need to do is type out the shape of our data on the left and then send it to the server on the right, and it will respond with JSON in the exact shape that we requested. And this is live data you're looking at that lives in the Firestore database. But it can come from any data source or even multiple data sources at the same time. The tweets also have a text property, so if we want to include text in our request, we just add that to the interface and it returns the text from the database. This can be extremely useful if you have relational data that you need to join from multiple sources, which is commonly the case with NoSQL databases. Let's imagine we want to query a user plus all of that user's tweets, which live in a completely different collection in Firestore. You can pass arguments to GraphQL, which in this case will be the user ID. Then we'll get autocomplete for all the properties available. So if we want to just pull the screen name, we can do that easily. But tweets can also belong to a user, and it's a property on the user interface. So we can apply it here and then request some data about the tweets that we want to return back that will only belong to this user. So that's really only the tip of the iceberg with GraphQL, but the main takeaway is that it allows you to request data in exactly the way it should be consumed in the front end, which is a big difference from REST APIs. Now we're ready to write some code, but first I have some really good news. Just a couple days ago, Node.js became available on the App Engine standard runtime, which means you can use it for free and it's super easy to integrate into a Firebase project. I first want to point out that you can find the full setup instructions on the GitHub repo for this video, but I do want to point out a few of the more important parts. I'll be writing this in TypeScript, but the code is fully compatible with vanilla.js if you prefer that. The first thing you'll want to do is install Apollo Server 2.0 as well as GraphQL. Then to make things fully compatible with TypeScript, there's a few extra things we added to the tsconfig, so make sure to grab the tsconfig from the repo. From here we can install Firebase admin, and then we'll need to go to the Firebase console and download our service account. You can find it under settings, and then go to service accounts, and then download it into the root of the project as serviceaccount.json. I've set up an index.ts file, and in this file I'm first going to import a few dependencies, starting with Firebase admin and then a reference to our service account, and then we'll initialize the app with that service account. That gives us full access to the data in Firestore. From here we'll import Apollo Server and GraphQL. We'll also bring in Apollo error and validation so we can handle errors gracefully on the server. There are two main pieces to a GraphQL API. The first one is your GraphQL type definitions, which is where you write actual GraphQL code to define the shape of the data that's available on the server. The second half of this puzzle are your resolvers. This is where you tell GraphQL how to return the actual data to the client through the API. So first let's start by defining our type definitions. You can define an object by calling type with the name of the object, And then there's a number of built-in data types. For example, ID is just a string that is supposed to be unique. Then you have common data types that you would expect, like string, integer, and things like that. When you put brackets around something, that means that it should return an array of that interface. You might also notice the exclamation point after each property. That just means the API will always promise to return that data type. It won't return a null value. So a user can have an array of tweets, which we've modeled here, but a tweet can only have one user. So we'll set some properties for our tweet object, but this time we'll type the user to the user schema that we just defined in the previous step. But if you look in the database, you'll notice that our actual user data doesn't have any tweets objects nested on it. Tweets are their own isolated collection that are completely decoupled from users. That's important to make note of because in the next step we'll use resolvers to combine all this stuff together. Now the last thing we need in our schema is the query, which can be thought of as like the main entry point into your API. In this case, we can enter the API through tweets, or we can enter it through the user with their user ID. At this point, everything that's available to be fetched on our API is well defined, but we still need a method to actually retrieve this data. For that, we'll define an object called resolvers, where each property in this object matches one of our interfaces. Data that already exists on the Firestore document can be inferred automatically, but remember we don't have any tweets available on the actual user itself, so we need to write a method that can resolve that data. In Firebase, this is really easy because we can use the admin database, call the tweets collection, and then just query where the user ID equals the user ID on this object. Then we call get to return that as a promise, and that'll be a snapshot, and the final step is to just map that snapshot down to its actual raw data object. If this code fails at runtime, we want to throw an error to handle it gracefully, which we can do inside of the try-catch block by throwing an Apollo error. Tweets will follow a very similar process. In this case, we just need to return a single Firestore document because every tweet has an associated user ID, but we want to be able to return additional data if the user requests it on their GraphQL query. The last resolver that we need is the query. This defines how we get the data for the root documents, being the tweet and the user. Tweets are a collection, so we can simply return those as a Firestore collection. So what we're looking at here is just Firebase 101. We're pointing to a collection and then retrieving it as an array of documents. The user query is also very similar, but the main difference is we're passing an argument to the method, being the user ID. We can access the argument data as the second argument in this method. So now we can retrieve our user based on the user ID that's passed in by whoever is making the GraphQL query. It's very possible that they will pass in an ID that doesn't exist, so we want to handle that with a validation error. If you remember earlier, we used exclamation points to only return valid types. If that user doesn't exist, we need to return a validation error instead. Okay, just a couple of lines of code left. We just need to combine these two pieces together by passing them to an Apollo server instance. The Apollo server feels just like an Express.js server. We just call listen on it and we're good to go. All you need to do at this point is compile your TypeScript code, which you can do with the tsc command, or there's a command in the main repo. When you run the script, you can pull up localhost and get the playground to start sending queries to your API. But we're not just going to stop here. There's this really cool thing called Apollo Engine that can handle things like caching and tracing, and it does it all in a really nice UI. You'll first need to register for an Apollo Engine API key, then all you need to do is add it to your Apollo server config, and you're good to go. This gives you access to a dashboard where you can monitor all the queries to see the exact latency of each one, and also inspect errors in real time. And let's also go ahead and deploy our app to a production server. Assuming you have the Google Cloud command line tools installed, all you have to do is create an app.yaml file with the Node.js 8 runtime in it. Run gcloud app deploy, and your GraphQL API is now available for the world to use. I'm going to go ahead and wrap things up there. If this video helped you, please like and subscribe. And stay tuned for the second installment where we build out the front end in Angular with the Apollo Angular library. And if you want to take things to the next level, consider becoming a pro member at angularfirebase.com. Thanks for watching, and I'll talk to you soon.